Welcome dear student to our YouTube channel. Today we will learn aldehyde ketone portion. In the previous two recorded classes, we have learned the basic portions of aldehyde ketone, and today we will learn the methods of preparation belonging to aldehyde ketone. So let's start. Methods of preparation of aldehyde ketone. So the why aldehyde and ketone are studying together, I have explained you that part because aldehyde and ketone contain the common carbonyl group, so their physical and chemical properties are nearly similar in most of the cases, so they are studied together. So I am explaining you firstly about the methods of preparation of aldehyde and ketone from alcohol by the method of oxidation. So let's start. First, preparation of aldehyde and ketone from alcohol by the method of oxidation. Different methods are there. So for the first method, so what do you mean by oxidation? We know from the concept oxidation means increase in the oxidation number value of the reactant during conversion of the atoms from reactant side to product side. In organic compound, we mainly deal with addition of nascent oxygen to the reactant during oxidation process. Mainly deal with addition of nascent oxygen. But in case of inorganic compounds, the increase in oxidation number mainly studied. But both the concept, that means addition of nascent oxygen, increase in oxidation number, explains about the oxidation process. So we know from the degree of carbon concept, carbon is of four types. That means if a carbon is not bonded with any other carbon atom or bonded with a single carbon atom, then such type of carbon is called as primary carbon. And if a carbon is not bonded to any other carbon atom or bonded with a single carbon atom directly, then that type of carbon is called as primary carbon or 1-degree carbon. That means I am telling it is a primary, which carbon? This carbon is primary carbon or 1-degree carbon. This carbon is also bonded to single carbon. So these carbons are primary carbon or 1-degree carbon. Primary or 1-degree carbon. Similarly, if one carbon atom is bonded with two other carbon atoms directly, then such type of carbon are called as secondary carbon atom. In a similar way, if a carbon is bonded directly with 3 carbon atoms, then that carbon is called a tertiary carbon. And the carbon, if bonded or surrounded by 4 other carbon atoms directly, then such type of carbon is called as quaternary carbon. So I am writing through example. It is a primary carbon. Now it is the second degree carbon or secondary carbon. Similarly, if the carbon is bonded with 3 other carbon atom, then that carbon is called as tertiary carbon. Similarly, what I have told, tertiary carbon, it is the tertiary carbon. It is the tertiary carbon as it is bonded with 3 other carbon atoms directly. Similarly, or third degree carbon. Similarly, if a carbon is bonded with 4 other carbon atoms directly, then that carbon is called as quaternary carbon. Quaternary carbon. So depending upon the degree of carbon, alcohol from which we are going to prepare aldehyde and ketone, alcohol is classified into 3 different groups. Why? There is 4 types of carbon. Why there is 3 types of alcohol is present? Because the quaternary carbon has no bonding tendency. So the primary, secondary and tertiary carbon has their tendency to produce bond. So they are producing different type of organic compound. If the functional group of alcohol is bonded to the 1 degree carbon, then it is called as primary alcohol. If the functional group of alcohol is bonded to the 2 degree carbon or secondary carbon, then it is called as secondary alcohol. If the functional group of alcohol is bonded to 3rd degree carbon, then it is called as tertiary alcohol. So alcohol is of 3 types, that means primary alcohol, secondary alcohol and tertiary alcohol, depending upon the degree of carbon. In this way, we classified the alcohols, and if you draw the general formula of alcohol from this example, so the general formula for alcohol or primary alcohol will be this part. We can say if you will put your hydrogen, it will be CH3, which belongs to alkyl group. So I am writing here R bond CH2 bond OH. It is the general formula for primary alcohol. It is the general formula for primary alcohol. Similarly, if you will put your H, it will be CH3, and if you will put your S, it will be CH3. So R CHOS R will be the secondary alcohols general formula, that means R CHOH R will be the general formula for secondary alcohol. Similarly, the tertiary alcohol will have the general formula, that means it will be the R, it will be the R, it will be the R, that means R will be the alkyl group. So 3 alkyl group will surround the carbon atom directly, and the functional group is attached to the tertiary carbon. It will be the general formula for tertiary alcohol. In this way, we find out 3 different general formulas for alcohol. In this way, we can go further how the alcohol will be involved in the formation of aldehyde and ketone. Write fast. After that, we will move for the methods of preparation. I am wiping the part. In this case, first I will explain which alcohol is involved in the formation of aldehyde, which alcohol is involved in the formation of ketone. So method I have already told, method is oxidation. So primary alcohol, I have told the general formula primary alcohol. Primary alcohol or 1 degree alcohol, primary alcohol or 1 degree alcohol is mainly involved in the formation of aldehyde, but in certain condition. What will be the condition we will learn later. Secondary alcohol is involved in the formation of ketone. The method should always be oxidation. The method should be oxidation for formation of aldehyde and ketone from their respective alcohols, but the tertiary alcohol has no effect of oxidation, so there will be no effect of oxidation, so it will be not involved in the formation of either aldehyde or ketone. But you should know first what will be the condition in which alcohol is converted to aldehyde. If we take during oxidation, 2 things occur, means if alcohol gets oxidized, dehydration occur. Why dehydration occur? Because during oxidation, the carbon atom which contains the hydroxyl group, that means the functional group of alcohol, it occupies another hydroxyl group which goes against the rule. That means if a carbon atom is bonded to more than one hydroxyl group, then the compound becomes unstable, and for the stability of the compound, one water molecule gets removed from that compound, resulting in a stable compound formation. So if one carbon atom contains more than one OH group or more than one hydroxyl group, then it releases water which occur during oxidation of alcohol. Either it may be a primary or secondary alcohol, dehydration occur to produce these both compounds. But for oxidation, we take two different type of reagents. One reagent is acidified potassium dichromate or potassium manganate, and another reagent is PCC, commonly used oxidizing agents. There are a number of oxidizing agents, but the commonly used oxidizing agents are PCC or Collins reagent or Corey's reagent. These are oxidizing agents used during the oxidation of alcohol to their respective compound. If you will take acidified potassium dichromate for the oxidation of alcohol to aldehyde, it will not be possible directly because acidified potassium permanganate or potassium dichromate only produces carboxylic acid, not aldehyde directly. So, for the oxidation of alcohol to their respective aldehyde, we always take PCC, pyridinum chlorochromate. So, I am writing the oxidizing agents first. After that, we will go for preparation. So, the two types of oxidizing agents. First, what I have told, acidified potassium dichromate. Dichromate has the formula or ionic formula Ca2O7 2-, potassium has the formula K+, so the resulting molecular formula is K2Cr2O7, and for acidified medium you can take any acid or H+ you can write. I am writing here sulfuric acid, or you can write H+. H+ express the acids. So these are the acidified medium for the oxidation of alcohol to aldehyde, and these are togetherly considered as the oxidizing agent. But this type of oxidizing agent has no tendency to convert primary alcohol to aldehyde. In this case, the carboxylic acid is formed due to oxidation or due to repeated oxidation. But if we will take PCC, I am writing here PCC, which express pyridinium chlorochromate. It is the full form for PCC, pyridinium chlorochromate. Anyways, pyridine. What is pyridine? Pyridine is a heterocyclic organic compound. Why it is called as a heterocyclic organic compound? If one or more carbon atom from a cyclic structure is replaced by the heteroatoms, that means oxygen, sulfur, nitrogen and phosphorus, the resulting organic compound is called as heterocyclic organic compound, because in a homocyclic organic compound each corner is occupied by the carbon atom, but in this case what happens, one end or one carbon end is replaced by the nitrogen atom, and the resulting compound is called as pyridine, and the pyridinum express here positive charge is present. That means here pyridine chlorochromate means here chromium oxide, that is CrO3, and hydrochloric acid are present in 1:1:1 ratio, which act togetherly as oxidizing agent. That means it helps the primary alcohol to directly get oxidized to aldehyde without going for oxidation into carboxylic acid. This is the main reagent which used for the direct conversion of alcohol to aldehyde. So I have told the basic difference between the acidified potassium dichromate and PCC, which are used for the oxidation of primary alcohol to aldehyde or primary alcohol to carboxylic acid. But if you take secondary alcohol, any type of reagent can be taken for the oxidation to ketone. So now we will study how the oxidation occurs in primary as well as in secondary alcohol. So let's start. First I am writing the general formula of primary alcohol, that means R bond CH OH. It is the general formula of primary alcohol. You can directly write RCH2OH. In this case I am writing the nascent oxygen here and expressing PCC here directly without taking acidified potassium dichromate, because I need primary aldehyde from primary alcohol. So I am writing here PCC, pyridinum chlorochromate, and in this case what will happen, one unstable product or unstable intermediate product will be formed. Why I am telling intermediate product, this is not the desired product we require. So we tell if during the conversion of reactant to product, the product which gets formed during the pathway of reaction is unstable, then that product is called as the intermediate product. And here the intermediate product is unstable because I have told the nascent oxygen part will be received by this hydrogen or this hydrogen. It will result in the formation of one hydroxyl group. I am writing here one hydroxyl group because this oxygen is moving to this hydrogen and one hydroxyl group is already present in the previous reactant. So in this case the one carbon is directly bonded to two identical OH group or two hydroxyl group or two functional group of alcohol. So it is gets unstable. So I am writing is the unstable, or it is the intermediate product. Due to unstable product, the one OH group will combine with the hydrogen atom, resulting in the dehydration process, and this will result in the formation of aldehyde. So R, I am writing here R, it will be C and the hydrogen is constant. But due to removal of hydrogen, the oxygen lacks its one valency, and due to removal of OH, the carbon lacks its one valency. So due to one unpair electron of carbon and one unpair electron of oxygen, double bond gets produced between carbon and oxygen, resulting in the formation of aldehyde. Along with the water molecule, that means H2O. As I have told, during oxidation, dehydration occurs due to formation of unstable intermediate product. So this is the complete process of oxidation of primary alcohol to its respective aldehyde. If you will put your H, it will result in the formation of methanol or formaldehyde. If you will put your CH3, it will result in the formation of ethanol or acetaldehyde. In this way, we can convert any alcohol to aldehyde directly by using the oxidizing agent, that is PCC. But in case of ketone, we need secondary alcohol. That means I am taking here secondary alcohol. It is the secondary alcohol's general formula, and in this way the same process will occur. It will result in the formation of unstable intermediate product, and this will result in the removal of one water molecule and will result in the formation of ketone, which is the result of oxidation of secondary alcohol. But ketone oxidation can occur by the help of PCC or acidified potassium dichromate. You should mark the difference first before understanding the concept. Let's move for another process of preparation of aldehyde ketone, and the next process belongs to dehydrogenation method. Whose dehydrogenation will occur? The dehydrogenation means, first I am writing the process, after that you will understand. What I have told? Method is dehydrogenation. And dehydrogenation means hydrogenation term express that this term hydrogenation express that addition of hydrogen, and D means removal. So D means removal means one hydrogen molecule will get removed from the alcohol. That means it will be primary alcohol, it will be secondary alcohol, or it will be tertiary alcohol. In this case, what will happen? During dehydrogenation, the hydrogen molecule will be removed from the alcohols to form the aldehyde ketone. But this process occurs when the alcohol vapors are passed over the red hot copper tube. the red hot copper tube allows the hydrogen molecule to get removed from the alcohol. In this process, we mainly prepare aldehyde from primary alcohol, ketone from secondary alcohol, and the tertiary alcohol is involved here, but we will not deal with that. The tertiary alcohol result in the formation of alkene. As the chapter belongs to aldehyde and ketone, we will mainly deal with aldehyde and ketone preparation. This portion will be taught here. It belongs to mainly plus to first year section. Let's move for the dehydrogenation process. I am writing the general formula of alcohol. That means I am writing at a time the general formula for primary alcohol and secondary alcohol here. First I have written the primary alcohol formula. It is the formula for primary alcohol, and the secondary alcohol has the general formula RCHOH. It is the secondary alcohol general formula. So what I have told, when alcohol vapors are allowed to pass over the copper metal and which is red hotted or at 300 degrees centigrade, the temperature which is given to copper metal is 300 degrees centigrade, and due to the passage of the alcohol vapors over the red hot copper, what happens? The hydrogen molecules gets removed from the alcohol, resulting in the formation of their respective compound, that means aldehyde and ketone. That means you should mark here, if the hydrogen atoms from the hydroxyl group will remove, oxygen lacks its 1 valency, and if the hydrogen gets removed from the carbon, it also lacks 1 valency. Due to development of 2 unpaired electrons over carbon and oxygen respectively, double bonds get established between the carbon and oxygen. That means RC double bond O, single bond H, and H gets produced, which is I have written extra H here, RCH double bond O here, and it belongs to aldehyde. And one hydrogen molecule here, hydrogen, 2 hydrogen is present, which gets removed from the alcohol due to dehydrogenation, and it is called as preparation of aldehyde from alcohol through dehydrogenation. You can mark here what happened in this case. If we will same thing occur what happened in primary alcohol, if we will pass the vapors of secondary alcohol over the red hot copper, then the hydrogen molecule gets removed, resulting in the formation of ketone. Along with the hydrogen molecule gets removed from the alcohol, it is the product for both aldehyde and ketone through dehydrogenation. So we have learned about how to prepare aldehyde and ketone from their respective alcohols through oxidation and dehydrogenation. I am taking you back to alcohol's oxidation for preparation of another aromatic section, that means benzaldehyde, and aldehyde's aromatic section, that is benzaldehyde, and the aromatic section for ketone, that is acetophenone, which is included in your syllabus. So first I am moving backward for the second portion. That means I have completed the open chain section of aldehyde and ketone. Now I am moving for closed chain section, that means for benzaldehyde and acetophenone section. So I am writing here method 3, or you can mention it in method 1 here also. What will be the method? The method is oxidation. That means the oxidation of alcohol to aldehyde and ketone. During this process, what happens? The benzyl alcohol is involved, because benzaldehyde is the derivative of benzene, which is called as benzyl alcohol. When one hydrogen of toluene, what is toluene? First we will know the structures, after that we will move for preparation. So when the benzene, one hydrogen of benzene gets replaced by the alkyl group, then it is called as alkyl benzene. It is the alkyl benzene. If the N value of alkyl benzene is 1, so what happens? It is called as methyl benzene and or toluene. methyl benzene or toluene, if that hydrogen of toluene is replaced by another functional group, that is alcohol, this part is called as benzyl group. This part is called as benzyl group. If one hydrogen or the vacant bond is occupied by the functional group of alcohol, then it is called as benzyl alcohol. It is the formula for benzyl alcohol, and benzyl alcohol is involved in the formation of benzaldehyde. Similarly, if it is a, first you can mark that I have told primary alcohol is involved in the formation of aldehyde and secondary alcohol is involved in the formation of ketone. You can mark here the carbon atom is primary because it is bonded directly with the carbon atom of benzene. So, and the carbon atom is bonded to alcohol. So, it is a primary alcohol containing organic compound, and the IPC name for the compound is 1-phenyl methanol. 1-phenyl methanol in the IPC name for the compound, but in our aromatic section we mainly deal with the common names. So, benzyl alcohol, if the functional group is bonded with the 2-degree carbon, that means what is the formula for the 2-degree alcohol? I am writing here. It is the benzyl group, and the benzyl group hydrogen, one hydrogen is replaced here. I am writing one hydrogen is replaced here and is occupied by carbon. If the n value of the carbon, or I am writing here directly carbon, that is CH3, it is the methyl group, and I am writing here one hydrogen. What I have done here, one hydrogen from benzyl I have replaced by the CH3, and I am writing here one OH, because in this case the degree of carbon is 2. In this case the degree of carbon is 2, so it will result in the formation of ketone, that is acetophenone. So now we will know how this process occurs during the oxidation or dehydrogenation. First I will explain the oxidation. You can tally the dehydrogenation what I have told in the dehydrogenation section. So I will go for only oxidation process. First I am writing the preparation of benzaldehyde from benzyl alcohol. So I am writing here the formula for benzyl alcohol. What happened? I have told in this case you can mark that 2A is present. So I am opening the structure. It is the formula for benzyl alcohol. If I will add nascent oxygen, it will undergo oxidation. For aldehyde, what I have told, we should always take PCC. But in this case, PCC is not used. So what are the reagent or oxidizing agent which are used for the properly oxidation of benzyl alcohol or for preparation of benzaldehyde and acetophenone? The reagent which is used for the preparation of benzaldehyde and acetophenone is MnO2 or manganese dioxide. That manganese dioxide is the proper reagent for the oxidation of benzyl alcohol to benzaldehyde and secondary benzyl alcohol to acetophenone. So in this case, one oxygen will go, the oxygen will go to this hydrogen. It will result in the formation of unstable product, and one water will be released. It will result in the formation of benzaldehyde. That means the carbon is present here. I am not writing the unstable product here, directly writing the main product. You can also write like that. So one oxygen and hydrogen, OH and H will be removed. So C double bond O will be here. C double bond O will be here and the hydrogen will be here. So it is the CHO you can mark, and the product will be benzaldehyde, as it is a primary alcohol containing organic compound, and it will result in the formation of byproduct, that is H2O. Similarly, if you will change the hydrogen here, it will result in the formation of acetophenone. It is the formula for acetophenone. It is the formula for acetophenone, which is the aromatic section for the ketone. In this way, you can go for dehydrogenation process. So I am also writing the dehydrogenation of alcohol by passing it through the red hot copper tube. You can also go for this. In this way, what will happen here? The two hydrogens, it is the benzyl alcohol, the two hydrogens will be removed and will produce in the benzaldehyde, benzaldehyde. It is the benzaldehyde, and it will release the hydrogen. The method I am changing here, dehydrogenation. Dehydrogenation, it resulted in the formation of benzaldehyde. Similarly, if we will change the value here to CH3, what I am writing here, CH3 here, it will also result in the formation of acetophenone. It is the acetophenone which we have prepared through dehydrogenation. So always remember the oxidizing agents or preferable oxidizing agents which are involved in the formation of aldehyde and ketone. It may be open chain organic compound or it may be closed chain organic compound. In this way, we can prepare different organic compound from a different chemicals may be involved in the formation of aldehyde and ketone. In the coming class, we will learn in detail about the different other methods for preparation of aldehyde and ketone. If you have any doubt in this lecture, comment in the comment section, share this video with your friend, ask them for subscribe to our channel. Thank you.